Alright, let's now talk about these large language models that are so popular. And we will start by talking about the two main ingredients. So originally the transformer architecture in the paper Attention is All You Need was developed for language translation, as we discussed in the previous videos. However, nowadays transformers or large language models are used for many other types of tasks. For example, there's this BERT architecture which is used for classification. Or we can use the popular GPT architecture for various text summarization and various text generation tasks. Yeah, and there's also ChatGPT, which you maybe have heard about, which is a conversational chatbot that can also generate texts. However, transformers are useful for other tasks as well. For example, here the AlphaFold architecture is used for protein structure prediction based on sequence data, namely amino acid sequences. But what all these transformers and approaches have in common is that there are two main ingredients that make them successful. The first ingredient is self-attention, which we already covered in Unit 8.5. The second ingredient is self-supervised pre-training, which we covered in Unit 7.7. Back then we talked about self-supervised pre-training in the context of computer vision. Now we are taking this concept and see how it works for transformers in a natural language processing context. So as you may recall, self-supervised pre-training is essentially a two-step approach. Step 1 is pre-training on a large unlabeled dataset. In this case, it's to learn a general language model. And then the second step is to fine-tune on a smaller labeled target dataset. Now for pre-training, we have two different approaches. One is to predict randomly masked words, and the other approach is to predict the next word. And different transformer architectures take different approaches, as we will see later. Now for fine-tuning, we also have two different approaches. One is to fine-tune all the weights that we have in the architecture, and the other approach is taking a feature-based approach where the model remains frozen and we just work with the output embeddings. And again, we will also see examples of those approaches later. So in the next video, we will start by seeing how pre-training works for GPT models.